Good morning, all. Am I audible? Hi, guys. Just do let me know in the comment section. Shall we start? Okay, I hope I'm audible. So let us start the session. So in the last three classes, we have been discussed about the basics of power electronics, basically. So we saw there are so many things we understood how to calculate the currents and basically how uh, transient is affecting creating impact inside the circuit. We understood so many properties and we saw the difference between IGBT, MOSFET, how they are being differentiated in terms of their frequency, input resistance, basically how we are dealing with them. Everything we have been covered, some fundamental basics. Now it's time to play with our rectifier circuits. Basically, they are playing a vital role in our power system. We all know the purpose of rectifier. What basically rectifier will do? I'm just asking you, just think a moment. What basically rectifier will do? We are having a variety of combination of switches. What it will basically do is, in this universe, we know majority of our electrical sources are generating AC power. But at some places, we are demanding DC power. Like there are so many applications in our home. If you take your mobile, it is in a DC. So the mobile applications, it is demanding DC power. When we are taking other applications in our home, if we take uninterrupted power supply, it is also demanding DC. If you take all small electronic applications, you can take your television, you can take your laptop. So all other electronic appliances are basically demanding DC power. But the power that we are generating in our power system is majorly generating what? AC power. So alternating current. What should I do? I need some equipment here such that this power, this AC power should be converted into DC. Okay, sir, that is what we want. What should I do for that? We have to do some action. That's all. Don't think too much. We are not going to do anything uh, very big. No, we are going to do some small actions such that the power will going to be easily converted from AC domain to AC domain, transferred from AC domain to DC domain. So that conversion process basically will be done with the help of some kind of switching arrangements. That is called filtering process, and we are simply calling it as rectification process. We are rectifying the AC energy into DC form. We are just converting. So what is the difference between AC and DC power? You might be wondering about these things already. Many of you people know this. Like, what is AC power? AC means alternating current. It will be having positive and a negative domain. So you can observe like this. But when you observe DC, what kind of waveform that I'm expecting? Understand, power electronics is very beautiful subject. It's playing a vital role in our power system engineering, in our domain. Because without this equipment, that conversion process from one domain to another domain, like from AC to DC or DC to AC or variable AC or variable DC, is impossible without these power electronic devices. So we are very happy to having this quantity in our home appliances such that we are getting whatever that we want. If you want variable frequency, yes, it is possible. Our Indian power system has been synchronized with the 50 Hz, but here we can get variety of frequency. So that's the beauty of our power electronic circuits. So see, basically DC means it will be a constant waveform. It is independent of time period. This waveform should be like this. Now you should be wondering, now sir, how these waveforms, see basically it is going like this, it is traveling like this, and then it is crossing 0 point, again it is going downward, again it is going upward. So it is the path that chosen by an AC supply is completely different from the path of DC supply. But somehow by doing some different mechanisms, we are going to do this. Let's make it possible. That is what we are going to do in rectifiers. So we are going to learn some beautiful schemes, arrangements in rectifier basically, and that will going to help us to do all type of what I can say to design all type of DC drives, apply electronic appliances that we want in the frequency that we are expecting. Okay, let's see. That's basically what we are doing in rectifier circuits. So these rectifier circuits can be designed with the help of, let us see. First of all, initially people started converting this with the help of a simple person who's called diode. Yes, a simple diode. Let's see how this diode is converting the waveform from one domain to another domain and how we are basically calculating. See, this is revision class. I'm not able to prove. I may not be able to do everything. You can watch these things in our lecture. I'm just showing the results or conclusions, how it is doing these arrangements. So when the moment I'm taking a DC supply and I'm connecting with a pure resistive load, I'm having a kind of R load in our home. So what I'm going to do is I'm taking a diode here and I'm connecting it with an AC supply. After that, I'm going to connect it with a load, and I just wanted to observe its waveform and how it is behaving here. This load is purely a resistive type load. So when we are connecting a purely resistive load, what will happen here? The load current, the current flow through the diode will be like this. Yes, sir, exactly. It will be like this. So in this case, when the moment you are closing this switch, where we are going to keep the switch? Let me do one thing. Let us create an arrangement here. This is the point where I was having a breaking. Now I am just simply closing it. When the moment we are closing it, what will happen? Diode will be short circuited. Basically, treat this diode is the ideal one. I haven't kept any voltage drop and I don't want to do that. That voltage drop is very small, so I'm neglecting it. So treat this diode is an ideal one. And when the moment we are injecting the supply voltage, RMS voltage Vs and a resistor R, simply if you observe in the output side, what I understood is this waveform should be simply coming to the output without any rectification process. So I can say the supply voltage will become C. Basically, current will be for an AC source. You can take any one direction. So let us say current will be traveling in clockwise. So current will be traveling in clockwise direction, and what will happen once diode is turned on? Automatically, it will be short circuited. Diode will be short circuited, and the current flow through the circuit will become. Let me write. Either you can write current coming out of the supply, or I can say current flow through the resistor, or I can say current flow through the diode. It will be equal to simply total supply voltage divided by total load offered by the circuit. Here, why I am not considering the diode? Because diode is short circuited. But now it is time to understand the property. See, how will you turn on the diode? Just do let me know. Actually, I have injected the AC supply. Yes or no? AC supply means it is alternating current. Basically, it is having two polarity. One is positive, another one is negative. Okay, sir. Now, when an AC supply is being connected with a diode, when in what condition the diode will be turning on? See, let us say, suppose now this alternating current carrying positive terminal here, negative terminal here. It means this positive polarity of the battery or supply is get connected with the anode terminal. So if anode terminal is carrying positive charge, by default cathode terminal will be going to carry negative charge. So I can say under this condition, anode voltage is positive, cathode voltage is negative. So I can say VA is greater than VK. That is anode voltage is greater than cathode voltage. This condition is sufficient to turn on the diode. So diode will turn on. So what you can do is you can short circuit the diode. This is the first case. Now suppose I am taking the same circuit. But what I am going to do in the second case is alternating quantity. See, this waveform should be in positive domain up to 0 to 180 degree. Yes or no? Understand everything. So till the first 180, so we can write omega t in the range of 0 to 180 degree. Only in this range you can observe this property number 1. So now it is time to understand the property number 2. Property number 2 means what will going to happen. Now the polarity will going to be reversed. Now what will happen across the same anode, negative polarity will going to be injected. It means by default cathode will going to carry positive. If you observe now, cathode terminal is carrying more than positive, that is more voltage than anode terminal will become greater than anode. Automatically diode will be turned off, and under this condition diode will be open circuiting. So it will be blocking the supply voltage. It will not allow the supply voltage to go anywhere. So in the first case, it is short circuited. In the second case, it is open circuited. So that is basically how your diode will be behaving here. Okay, sir. Now you might have understand that is very easy to rule. Okay, now if I am passing this waveform, if you pass this alternating quantity through the diode, then what type of waveform you will be observing in the output side? See, in the first half, from 0 to 180 degree, when I was passing the AC current, what happened? Diode is short circuited. If diode is short circuited, then immediately see, only we have three elements. One is supply voltage, another one is diode, another one is resistor. When diode is short circuited, then supply voltage will be simply dropped across the resistor. See that first case diode is short circuiting. It means this positive property of the supply voltage will get reflected across the resistor. So positive voltage will be dropped across the resistor from 0 to 180 degree. What will happen after 180 degree? Now think of it. Sir, after 180 degree, the negative zone, this negative portion will be blocked by the diode. So what is see here I am drawing the output waveform. Output waveform means I am measuring the voltage across the resistor. I can say this. So positive voltage will be this positive energy, this positive voltage will be transferred to the output. What about negative portion? Negative portion will be blocked by the diode. So here the conclusion is in the same positive zone, if I will draw the waveform for the diode, what you can observe here is in the positive of 0 to 180 degree, there will be no any drop across the diode. So I can say the voltage drop across the diode will be 0. Why? Because the supply voltage will be transferred to the output. What about the after 180 degree? What will happen? After 180 degree, diode is acting as a open circuit. It means what? Diode acting as a open circuit means it is blocking the supply voltage. So the second half of the supply voltage will be, you can observe across the diode. So this supply voltage will be broken into two of positive will be appearing across the output, negative will be appearing across the diode. This is the first property that you have to observe completely. But if you observe, if you add the output voltage plus voltage drop across the diode, addition of these two will give you the value of supply voltage, that is satisfies the KVL, Kirchhoff voltage law. According to Kirchhoff voltage law, supply voltage will be equal to voltage drop across the loads. So voltage drop across the diode plus voltage drop across the output load. So is it satisfying or not? Yes, if you merge the waveforms of the diode and output, you will be coming back to the source. Our condition will be satisfied here. But what I need is, I'm having some kind of load. Across that load, I'm expecting some DC power. But how the DC voltage current will be looking like? See, DC means it should be like this. Without ripple, I need a straight line. But I'm not getting it. But what I understood is, initially, one thing what I successfully done is, I was injecting AC. AC means alternating polarity, positive and negative. But now, successfully in the output, I am receiving only positive. If you observe, with respect to time period, if you observe the output voltage, see there. From 0 to 180 degree, we are having positive voltage. After that 180 degree, we may have some zero voltage. Some 180 to 360, it will be 0. Again, what will happen? After 360, same waveform will be appearing once again. Same 180 degree. Again, after 180, so it will be 0. Like that, I am getting some only positive polarity. So DC means a single polarity. Either you can carry positive or you can carry negative, but both waveform we can't carry. So successfully in this research, what I completed is I can carry only positive waveform with the help of diode. Now by keeping different loads, you can observe the same things for all other people also. So here what you can do is, okay sir, output simply the replica of the input voltage. We can simply write like this. Whatever the things that you are keeping at the input side, it will be simply reflected across the output. That's what you have to understand here. Okay sir. Now it's time to understand, okay sir, if I'm connecting this diode, see this is basically how we are doing the rectification process. Okay, so before proceeding further, now instead of connecting the AC sources, I am going to connect the DC supply alone, because in the examination, initially we are going to do the analysis how this diode is behaving with the DC supply with a different load. With this, there are so many questions in the examination. Are you getting me? Here, I have done the rectification process, but now what I am going to do is I am going to take a DC source. There are so many questions from this concept. If we connect the diode with the DC source, what will happen at the output side for different loads? Based on this, there are so many questions. So let us understand with the DC. After that, we will be again starting the rectification process, because we are doing the research. First, let us connect the diode with the DC supply, and we will connect the variety of loads and see how beautifully he is behaving here. After that, we will be switching to AC from DC. Okay, so right now I am taking DC source. Do remember, I am taking DC source. Let us start our operation with the DC source now. It is quite easy, right? Okay sir, if I am doing the same thing with the DC, tell me what will happen. So I am taking a DC with the diode circuit. After that, I am simply connecting like this. Let us see, this is positive, this is negative, and here we are having the diode, here we are having the resistive load. What kind of observation you can do here? Just simply tell me. See there, definitely it's a battery. DC means there is no point of discussing about alternative polarity, we will have a single polarity. So for a source, current leaving point should be plus, current entering point should be minus. We all know this. Yes. So for this diode, automatically, when the current is entering, what will happen? Through anode to cathode, we are going to see. If you observe, positive terminal of the supply is connected with the anode. By default, cathode will going to be negative. So this diode will be short circuited. Then what will happen? Current will be going like this. Current entering point will be plus, leaving point is minus for the resistor again. So this current will be coming back. That's this operation is over. Now let me call this current, either you can call it as source current, or you can call it as IR, that is current flow through the resistor, or you can call it as ID, diode current. Now what will happen? Simply you can observe here, nothing will happen when the moment you are trying to inject the supply voltage. So basically here we will be need a switch. Let us assume there is one switch, that switch is closed at t equal to 0. So let us draw the waveform at t equal to 0, from t equal to 0 onwards. If I draw the waveform, so basically supply voltage we are injecting a DC supply. Now if I will observe the property of the diode, across the diode you will not observe anything. Diode will be simply short circuited, so the voltage drop across the diode will become 0. Why sir? Why? Because diode will turn on. So once diode will turn on, then it will be short circuited. Okay sir, what about output voltage? Output will be simply following input here. Why? Because diode will be short circuited. According to Kirchhoff voltage law, supply voltage will be equal to voltage drop across the loads. So here there are two loads, one is diode and another one is your resistor. But since diode is short circuited completely, so this voltage, supply voltage must be equal to voltage drop across the load. This is output voltage. So I can say the voltage drop across a resistor or output will be simply equal to supply voltage. It is same as the supply voltage. Now how will you find out the current waveform? Current also similar to this. Simply what will happen? current flow through the resistor will become simply voltage drop across the resistor, that is equal to supply voltage divided by resistor. Now what you have to understand is the property of current. The waveform of the current will be similar to voltage, but magnitude will be less than the supply voltage. Why? Because here the current value will become voltage divided by resistor value. So based on this resistor, maybe current will be decreased or increased, but waveform structure will be similar. Only the magnitude will be different. It depends on the value of R. So this is how we are drawing, how we are analyzing this circuit. Simply we can do like this. Okay, sir. Now suppose if your supply voltage is 100, then the voltage drop across the resistor also will become 100, and take resistor value is some 50 ohm. Then current flow through the circuit will become 2 ampere. That's all. So you can say current flow through the circuit is 2 ampere. Supply voltage will be equal to 100 voltage. Load voltage also will be equal to 100 voltage. That's all. You can draw like this. So this is how your diode will be basically behaving when we are connecting DC with a resistive load. Okay, sir. You might have understand this. Now let us understand. See, in power electronic circuits, it is very important to understand the switching behavior, how to draw the waveform for all people, and how to develop the voltage equations. Then only you will be able to play with these circuits. But it is very easy subject. Just with the help of basic circuit theory, we can play with this. Fine. So let us continue. The second thing. Suppose this time I will keep a switch properly. Let us assume I'm having a switch here. As usual, we are having a diode. And now let us connect one resistive load plus inductor, RL load. Okay, and here we are going to connect as usual DC supply. Let us see how it will be pumping here. Guys, I can't explore everything here. This is a training session. So I have to start a problem soon. So it is your responsibility to recapture everything. So kindly spend some time in our lecture to understand everything. Okay. So this is our output voltage. This is voltage drop across the diode. Let us close the switch at t equal to 0. Okay. Now, if we are observing the RL circuit, when we are observing the RL circuit, it is very important to know the behavior of the circuit. How do we find out the current and see? One thing what you have to understand is, once again, first analyze the diode. Positive polarity of the supply is connected with the anode when the moment we are closing the switch, and the negative of the supply will be connected across the diode, sorry, cathode terminal. Definitely this diode will turn on and it will be short circuited. Once it is short circuited, you can observe, sir, it is the DC supply with the RL circuit. Definitely what you can observe, RL transient circuit. We can say this circuit is RL transient. So it's definitely you will be observing the behavior of, that is, you will be observing the nature of transient behavior here, because it is RL circuit. Inductor is there, it will be playing. So what you have to do is, first step is find out the current flow through the inductor IL of t. Since inductor, resistor, supply all are connected in series, so I can say current flow through the inductor, current flow through the resistor, current flowing through the supply all are equal. Now you know how to write down the expression for current flow through the inductor. Just to take initial current is as usual 0. Now it is your responsibility to find out the final current and everything. What will happen? In the final stage, inductor will be short circuited. So supply voltage will be simply dropped across the resistor. So we can say it is R, this is L. So final current will be equal to supply voltage divided by resistor, or IL of infinity. How will you derive this expression? IL of t equal to Guys, kindly recapture these things in our lecture. I cannot derive everything, I'm repeating. So IL of infinity plus IL of 0 minus IL of infinity into e power minus t upon tau. So from this expression, just to substitute, IL of infinity is equal to Vs by R. Same here. But here this value is going to be 0. Tau equal to simply L upon R. Finish. Substitute everything here. You will be coming up. See, Vs by R, one more, minus Vs by R into e power t minus tau. I am taking it out. So it will be 1 minus e power minus t by tau, whereas tau is equal to L by R. This is the expression for current flow through the circuit. Now it's time to explore the voltage across the inductor. So you know how to do that. That is the next most repeated question in this circuit. The voltage across the inductor means V is equal to L into di by dt. V is equal to L into dIL of t, current flow through the inductor divided by dt. How will you do that? L into, just to differentiate the above expression. See, this is IL of t. I just need dIL of t by dt. If I will differentiate this, then Vs by R is constant. I am keeping it outside. This 1 will be 0. Then 0 minus e power minus t by tau is again same. But internal differentiation, if you differentiate minus t by tau, that will give you minus 1 by tau. So finally, it will be equal to, that is the voltage drop across the inductor VL of t equal to L into Vs upon R. If you observe, see that this minus into minus will be plus. So I am putting into plus 1 by tau into 1 by tau only, minus will not be there. Tau is equal to L by R, so I am replacing tau by L by R into e power minus t by tau. So this R will be cancelling, this L will be cancelling out. So finally what you will be observing here, it will be simply equal to supply voltage Vs into e power minus t by tau. See the beauty of this circuit. So this transient effect is the only problem in this circuit, e power minus t by tau. That will be dies out after some time. Okay. Okay, sir. Fine. So we understood how to calculate the voltage drop across the inductor and current flow through the inductor. Now here, one more question what will be getting repeated in the inductor is initial rate of rise of the current is dash. Like basically, you'll be asked to calculate the value of DIL of 0 plus by dt. And it is very simple to calculate. We know we have seen in circuit theory transient lectures how to calculate this DIL of 0 plus by dt. How will you do that? We know in inductor V is equal to L into di by dt. This is the formula. If you want to know the value of DIL of 0 plus by dt, simply pass this L to the left hand side. Find the voltage drop across the inductor at t equal to 0 plus divided by L, such that you will get the answer. That's all, it is over. Now, can you please explore what is the value of VL of 0 plus, that is at t equal to 0 plus instant. I just wanted to know the voltage drop across the inductor. Anyone can me help me? It will be equal to what? What is the expected value of the voltage drop across the inductor at t equal to 0 plus? Let me tell you. How will you do the analysis? For that, RL circuit means we have to find out the value of IL of 0 minus. IL of 0 minus is 0. We are closing the switch only at t equal to 0. So prior to that, this circuit is open circuited. In open circuit, current cannot flow. So I can say IL of 0 minus is 0. When IL of 0 minus is 0, definitely IL of 0 plus also going to be 0. Current flow through the circuit 0 means it indicates that the given circuit is open circuited one. Inductor is open circuited. When inductor is open circuited, then how will you draw the circuit? See, we are closing the switch at t equal to 0, inductor will be short circuited and only resistor will be there. Sorry, diode will be short circuited, only resistor will be there. But inductor is behaving as a open circuit. This is the condition at t equal to 0 plus. Now tell me what will happen here. When this circuit is open circuited, current will be 0. Yes or no? In open circuit, basically, this is the behavior of the inductor in this case. Open circuit means almost it is acting as an insulator. Yes or no? Because open circuit resistance will be approaching to infinity ideally. Practically, it will be very high. When resistor is approaching to infinity, current will be approaching to 0. This property we are observing only in an insulator. So I can say it is behaving as an insulator, so current will be 0. Now tell me what is the voltage drop across the resistor. If you want to know the voltage drop across the resistor, it can be written as current flow through the circuit into resistor. Since current is 0, so voltage drop across the resistor will be 0. So this resistor will become useless now. Then what is the expected voltage across the inductor? This supply voltage will be simply blocked by the inductor. It will be reflected across the inductor because there is no any other sources. In open circuit, voltage will be available. In short circuit, current only will be available. So in open circuit, the supply voltage will be completely blocked or dropped across the inductor. So other elements will become useless now. Okay, sir, fine. So what I can say, what I can simply say is The voltage drop across the inductor at t equal to 0 plus will be simply equal to supply voltage. Yes or no? Now come back and write the expression for this. So it will be equal to simply supply voltage divided by inductor L. This is most important thing. Guys, don't memorize anything because these all things already we have been discussed in transient analysis of DC circuits. But try to understand how to do this analysis. Okay, slowly explore your knowledge. அது நம்ம எப்படி இதோட applications explore பண்றோம்னு பாருங்க. See, இதெல்லாம் நம்ம ஏற்கனவே பார்த்தாச்சு. That is what I am telling. If you are very good in circuit theory, you will be able to crack all the questions from power electronics, power system, electrical machine, analog electronics, electrical measurements. They will become very easy. You can play with them. Fine. So now you might have understand all these things. Let us go ahead with the RC circuit. It's time to play with the RC. So we have understand RL circuit now. So let me take the same circuit once again. Let us pump up. Consider a switch. Again I am considering a diode. Once again let us consider R and C. If I will connect a capacitor here, let's see what will happen. Okay, diagram is ready. Okay, sir. As usual, close the switch at t equal to 0. This is the diode, and here we are going to keep our DC supply. DC or supply voltage Vs simply, no issue. And this is R, this is capacitor C. Across this hole, we are going to measure the output voltage V0. Fine, sir. This is the basic behavior. As usual, here for the RC circuit, we know whenever we are dealing with the RC circuit is connected with the DC supply. See, positive plate of the supply is connected across the anode, negative will be connected across the cathode. So diode will be turned on with the moment you are closing the switch. So while closing the switch, diode will be turned on. Turn on means it will be short circuited because we are having ideal diode here. So it will be short circuited. Fine, sir. Once it is short circuited, then what will happen? It is time to explore the properties of voltage RC circuits, right? Okay, sir. So how do I do that? It is very simple. Let us see. The thing is, I told you in case of RC transient analysis, the first step we have to explore the value of voltage drop across the capacitor. Then only you will be able to analyze other parameters because capacitor only will be opposing all the properties of the circuit due to moment of inertia. So this is the formula. How will you explore? Once again, calculate the value of Vc of 0 minus. The initial voltage is not given. Initial voltage drop across the capacitor is not given. So by default, you can consider this value as 0. What about Vc of infinity? Infinity means your circuit will be open circuited. Right? இப்போ நம்ம இண்டக்டர் அனலைஸ் பண்ணோம் இல்லையா, அதே மாதிரி இப்போ என்ன பண்ணோம் அப்படின்னா கெப்பாசிட்டர் பட் டைம் t equal to infinity ல see diode will be short circuited and we have only resistor. At t equal to infinity, the behavior of the capacitor will be what? When a capacitor is permanently connected with a DC supply for a very long time, its behavior will be open circuited. When an inductor is permanently connected with a DC supply for a very long time, its behavior will be short circuited. Okay, so this is the resistor R, and here we are having the supply voltage Vs. Fine, sir. Now what we are going to do? Let us do that. Now tell me, in open circuit as usual, current flowing through the circuit will become 0 ampere. So the voltage drop across this resistor will become 0 voltage. It will be useless. Then what will happen? This total supply voltage will be reflected across the capacitor. So I can say at t equal to infinity, the voltage drop across the capacitor will be equal to supply voltage. So you can replace here Vc of infinity by Vs. And you know for the RC circuit, time constant tau is equal to R into C. So let us substitute all the values. So it will be supply voltage Vs minus Vs into e power minus t upon tau. Tau equal to RC, we all know. Now you can take Vs outside into 1 minus e power minus t upon tau. Okay, this is the complete voltage drop across the capacitor. Once you figure out the voltage drop across the capacitor, it is time to explore the current flow through the capacitor, IC of t. You know how to do that. I is equal to C into dVc of t upon dt. Same analysis like our inductor, but in inductor we will be starting from current. But in capacitor, we have to start from voltage. Okay, sir. Now, let us differentiate. To know the current flow through the capacitor, IC of t equal to C into, where is VC of t? This is VC of t. If I will differentiate it with respect to time, VC is constant. Internally, see, differentiation of this one will be 0 as usual, 0 minus e power minus t by 2 once again will become e power minus t by tau only. Internal differentiation will give you minus 1 by tau. So see, now there are two minus into minus 1 by tau. It will be plus. Now C into Vs into 1 by tau can be replaced by R into C into e power minus t by tau. So now this capacitor voltage C will be getting cancelled out. Finally, you will be coming up with the Vs by R into e power minus t by tau ampere. This is the generalized current flow through the whole circuit, not only through the capacitor. Since all the elements are connected in series, so current flow through the resistor, current flow through the capacitor, current flow through the supply, everything will be same. So now I have derived both voltage expression and we have also derived the current expression. Understand? I hope you all got it. Now I just wanted to know something. Can you please help me to do that? Listen. What we have understand is here we found the expression for voltage. Similarly, RL circuit we have analyzed. We know the expression for both voltage and the current. See, current expression is here. This is the current expression, and this is the voltage expression. Similarly, here I have done the expression for current flow through the capacitor and the voltage. Can you please draw the waveform for all the people? So let us take. First, if you take the current flow through the inductor, what we are observing, let us take voltage. Voltage is, where is this? This is Vs into e power minus t by tau. So let me write here. So we understood for a RL circuit, voltage drop across the inductor. It will be simply Vs into e power minus t upon tau. Now in RC circuit, Vc of t, we observe that it is Vs into 1 minus e power minus t by tau. Just now we have explored. See, in this is Vc of t. Similarly, if you observe RL circuit, IL of t is Vs by R into 1 minus e power minus tau. See, if I will write the expression for IL of t, it will be 1 minus, it will be Vs by R. 1 minute, guys. Yes, let me write. So it should be Vs by R into 1 minus e power minus t upon tau. Similarly, if we will be writing the expression for IC of t, what we observed, it is where is Vc by R into e power minus t, that is Vs by R into e power minus t upon tau. Okay, sir. Now this is RL circuit, of course. This is RL circuit, of course. This is RC circuit, yes, of all. This is RC circuit, yes. Let us draw the waveform for all these people one by one. When I will observe the RL circuit, first let us take RL circuit. RL circuit, I am taking VL of t. First, let us draw the waveform for voltage offered by the inductor. 1 minute. Yes. Tell me what will happen at t equal to 0 instant. I need only 2 instant, t equal to 0 and let us approach t equal to infinity. I will take two cases. At t equal to 0, what is the voltage offered by the inductor? Take this expression, replace t by 0. If I will replace t by 0, then e power 0 will be 1. So I can write VL of 0 equal to, it will be simply Vs. Why? Because when we are replacing t by 0, e power 0 will be 1. So it will be equal to simply supply voltage. So some DC voltage will be appearing at t equal to 0. Let's see after that what will happen. So when I am approaching t equal to infinity, if I will replace t by infinity, what I will be getting? So it will be Vs into e power minus of infinity. It will be e power minus infinity equal to 0. So 0 into. So what we have understood is initially the voltage offered by the inductor is equal to DC voltage. But finally this voltage level is decreased to 0. So that is what we have to understand. So it is approaching to 0 at t equal to infinity. Its waveform will be like this. Now if I will draw the waveform for the current. Sir, each and every time you can check. Waveform வந்து நான் சும்மா இது எப்படி இருக்குன்னு மட்டும் தான் நான் காட்டுறேன். ஏன்னா நான் calculate பண்றது only 2 time period. நீங்க full-ஆ calculate பண்ணிக்கணும்னா you can do it. Okay, fine sir. Now let me draw the waveform for current flow through the inductor IL of t. Where is that? So IL of t is written here. Replace t by 0. So if I will put t equal to 0, then IL of 0 will be coming. T equal to 0 means, see, Vs by R into Vs by R only into 1 minus e power 0 also will be 1. So it will be equal to 0 ampere. Initially there will be no current. If I will replace t by infinity, then you can be observed. IL of infinity. E power minus infinity will be 0. So you will be coming up with the Vs by R. So the current waveform is basically, let me draw it a little proper way. What happening is the value of the current is initially 0, but it is slowly increasing. Sorry guys, it is slowly increasing from 0 to a certain level. After that it will become constant. Yes or no? It is charging, it is increasing to, actually it is exponential increment, right? Fine. So this is how current waveform will be observed for inductor. Similarly, in the same way, can you draw the waveform for capacitor? See, in the examination, they will be giving you the waveform also. That's why I'm drawing these things. So it is very important to understand how to draw the pattern. First, you have to identify the expression. Then it is easy to draw the waveforms. Now repeat the same thing for capacitor voltage and capacitor current. Shall we start? Yes. Let us go ahead with the voltage drop across the capacitor. It is here. If I will replace t equal to 0, then e power 0 will be 1. So 1 minus 1 will be, once again it will be 0. Initially it will be 0. So later what might have happened? You can observe here later. So at t equal to infinity, e power minus infinity will be 0. So 1 minus 0 will be 1. So Vs. So it will be slowly increasing, 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 and then it will become constant like this. This is voltage drop across the capacitor. What about the current flow through the capacitor IC of t? Let us take that. See this one. If I put t equal to 0, it will be Vs by R. Initially this value will be Vs by R. Later on, if I put t equal to infinity, that will be 0. So if you observe the current flow, it will be decreasing, right? So this value will be, sorry, initially it will be constant. Then it is slowly decreasing to 0. See, the basic property of the current flow through the capacitor and voltage drop across the inductor will be remains, because they are dual each other. Dual each other means inductor and capacitor are always dual of each other. It means in place of L, if you replace C, it will be reflecting the property of capacitor. So what you have to do, if you replace voltage across the inductor by current flow through the capacitor, and current flow through the inductor by voltage across the capacitor, it will be giving from the inductor circuit you can derive the property of capacitor circuit. This is called duality. That things we have already discussed in circuit theory also. So they are dual to each other. See the property of inductor. If I will replace VL of t by VL by IC, are you observing the property of IC of t or not? Because they are dual each other. If I will replace IL of t by VL of t, are you observing the same property or not? Their voltage magnitude might be different, but their property will be remain same. They are dual each other. That is called duality. Okay, this is how we are developing the waveform pattern for all these people. Okay, do remember these things, because some kind of one more question will be directly asked in your examination. No need to memorize. Understand the circuits. That is enough. Okay. Now we understood RL circuit and RC circuit properly. Now it is time to explore LC circuit. Slowly I will be dropping, I will be stopping doing all this analysis. It is your responsibility. I'm just covering some small things that are required for you. Okay. So now when we are taking LC circuit, how will be, once again, let us pump it. I need a switch. Then I need a diode here. Yes, this is our capacitor. Let me connect a DC supply with this. This will be our circuit. What we have to do, we have to close the circuit as usual at t equal to 0. Yes or no? Yes, sir. So here the supply voltage will be Vs, voltage drop across the diode will be Vd, and the voltage drop across the LC circuit. This is where we are going to observe the output voltage. This is the complete analysis. Okay, sir. Now it's time to draw the waveform pattern, everything by you. See, this derivation is a little bit lost. What I'm doing is I'll be writing the expressions directly. Later on, by watching our lecture, you can see how it came. It has been derived, okay? Because it is waste of time. I can't do everything here. So what I am directly writing is, if we observe the voltage drop across the inductor, what you will be observing is, it will become like this. The voltage drop across the inductor will be, I think it will be equal to yes, supply voltage into, you will be coming up with the cos of omega t. Okay. And similarly, if you derive the expression for voltage drop across the capacitor, that is the next important. So that will become, it will be Vs into 1 minus cos omega t. This is LC circuit. Remember, inductor and capacitor will be playing themselves. So they will be creating oscillator waveform. You might be wondering, sir, நம்ம apply பண்ணது DC sir. நீங்க என்ன வெளியில காசுலாம் போட்டுட்டு இருக்கீங்க? Do you know how the waveform of cost will be looking like? It's an alternating quantity. Yes, it's happening. Why? Because inductor and capacitors are opposite to each other. If inductor is carrying positive energy, capacitor will be carrying same amount of negative energy. If inductor is having 20 joules positive, capacitor will be having minus 20 joules negative. But it is not always same. Sometimes it will be same, and the remaining time one will be having positive energy, another one will be having negative energy. So they will be started playing themselves. So that energy transformation will be like this. They will be oscillating themselves, vibration. Positive energy will be going from inductor to capacitor, negative energy will be coming from capacitor to inductor, again that negative will be going from inductor to capacitor, like that. That positive negative domain transformation will be creating finally alternating quantity across the LC circuit. That's the beauty of LC circuit, you know. It's really very beautiful to observe this phenomena. Sir, I wrote the expression for voltage drop across the inductor. I wrote the expression for voltage drop across the capacitor. Supply voltage is written. Something is missing. What is missing? Current flow through the inductor, or current flow through the capacitor, or current coming out of the supply. Anyway, since all the people are connected in series, so they all will be same. Most important repeated question. So here what you can do is, this value will be simply supply voltage into square root of C by L into sine of omega t. Okay, so exam maximum current that can flow through the LC circuit when it is connected with the DC supply. So this is the peak current, we can write. This current is considered as peak, means maximum, don't think too much. This is called maximum current. This will be equal to supply voltage Vs into square root of C by L. Now can you do a small favor for me? I just wanted to know the waveforms of all these people. How will you draw the waveform for sine waveform, sorry, sinusoidal waveform and cosine under this current experiment? I just wanted to know the waveform pattern, because that is very important in this case. Okay, you will be asking many times, this question will be asked in the examination. And in the most one more question, you have to identify the conduction period of the diode. Conduction period of the diode, because நம்ம இதுக்கு முன்னாடி பார்த்த waveforms எல்லாமே வந்து different. நம்ம DC தான் கொடுத்தோம், அவுட்புட்ல DC தான் வந்துச்சு, but with the transient effect we have been observed RLC, RC, RL. But in the LC circuit la varumbodhu sinusoidal components are existing. So it is sometimes diode will be blacked, sometimes diode will be short circuited. So we have to identify the conduction period of the diode. I hope many of you might know the formulas. It's okay, let us revise one. Nothing will be there. Conduction period எவ்வளவு வரும் அப்படின்னா omega into t will be equal to 180 degree, or in radiant I can say it will be pi. So from this I can say t is equal to pi by omega Since we are having LC circuit, so the frequency will be basically approaching to resonating frequency, that is omega equal to 1 by square root of L into C. If you substitute that value, then conduction period of the diode will be coming pi by 1 upon square root of L into C, or I can say it will be pi into square root of L into C. So in LC circuit, the conduction period of the diode will be equal to pi into square root of L into C. Don't forget, this formula is most important. At the same time, don't memorize also. Understand how it is being derived. Okay, fine, sir. Now I hope you all have understand this. The conclusion next what you have to do is, see what they will be asking you is at omega t equal to 90 degree in LC circuit, at omega t equal to 90, what they will do is they will be giving in radiator at omega t equal to pi by 2. What is the expected voltage drop across the inductor? What is the expected voltage drop across the capacitor? What is the expected current flow through the circuit? What will you do? What will you do? You know the expression of voltage across the inductor. Substitute omega t equal to 90. Cos 90 will be 0. So the voltage drop across the inductor will become 0. That is how questions are being framed from this area. So now it is time to draw the waveform for all these people. So let me draw the waveform also, right? Only for this circuit. For all I can't do, but this is a little bit important. So let me do that. So let us take, first we will write the expression here one more time. Nothing is wrong. VL of t equal to supply voltage Vs into cos of omega t. Then Vc of t, voltage drop across the capacitor, will be equal to supply voltage Vs into 1 minus cosine of omega t. Similarly, if I write the expression for current flow through the whole circuit, or current flow through the inductor, or I can say current flow through the capacitor, or I can say current flow through the supply, will be equal to Vs into square root of C by L into, it will be sine omega t. Yes or no? Yes, sir. Now let me draw this waveform from inductor. So first I have to draw a straight line for that. Let me somehow try to manage this. Yes. So let us take omega t versus VL of t. Let me break this 0 degree. Then we will go 90 is sufficient. Then we will take 180. Then we will go 270. Then we will go up to 360. Okay. This much is sufficient for us. What will you do now? Let us explore. If I will replace omega t equal to 0 degree first, tell me what is the value. Only focus on inductor expression. Omega t equal to 0, cos 0 will be 1, so 1 into Vs will be Vs. So starting point, the voltage will be equal to supply voltage, some value. At omega t equal to 90, it will be 0. So this waveform will be slowly decreasing to 0 at omega t equal to 90 degree. Then what will happen? At omega t equal to 180, it will be equal to minus 1. Cos 180 will be equal to minus 1. Cos pi, that will be minus 1. So minus 1 into Vs will be equal to minus Vs. So it will be reaching minus Vs. So this value will be reaching maximum peak voltage in the negative zone, that will be minus Vs. It is going from plus Vs to minus Vs in 180 degree. Okay, after 180, what will happen? Let us focus at 270. Cos 270, obviously it will be 0. So again it will be decreasing to 0. At 360, cos 360, once again it will be 1. So again it will be reaching to maximum value, right? So this is how this waveform pattern being observed at various points. Let us do the same analysis for all other people. It means I have to draw the waveform for capacitor now. Shall we start? Yes, start Pranama. Can you please draw it? Instead of waiting for me, you can draw it by yourself. So as usual, we are starting from 0. Then now it is, I have to drop it. So it will be 90. Then this will be 180. It will be 270. This will be 360. Start பண்ணலாமா? Okay, sir. Do it. Do the same thing. At omega t equal to 0. Cos 0, 1. 1 minus 1, 0. So here, the voltage drop across the capacitor will be initially 0. Now let us see at omega t equal to 90 degree. Cos 90 will be 1. Right? So listen. What I am observing here is when I was putting cos 0 is 1. But cos 90 is 0. So 1 minus 0 will be 1. So 1 into Vs. So the level of the voltage will be shifted to Vs now. At this point, we will be going to Vs. So let me slowly increase the value. It is going to Vs. Next, if I put cos 180 equal to minus 1. Already one more minus is there. So 1 minus of minus 1 will be equal to 2. So again, what's happening here? So this value is increasing to 2s to 180. So here, this value will be striking out. So 2 times of supply voltage. Remember, we are observing something new here. Supply voltage அப்ப நீங்க 100 கொடுத்தீங்க அப்படின்னா the voltage drop maximum peak voltage drop across the capacitor வந்து என்னவா மாறுது twice of the supply voltage அப்போ 200 voltage வரும். This is the gate question. ஒரு டைம் கேட்ல கேட்டிருந்தாங்க இல்லையா supply voltage வந்து 100 voltage நம்ம provide பண்ணோம் அப்படின்னா for the LC circuit I don't remember that value. This is random value I'm putting. என்ன கேட்டிருந்தாங்கன்னா maximum voltage drop across the capacitor அப்படின்னு கேட்டாங்க in an LC circuit. In a LC circuit. இப்போ LC சர்க்யூட்ல நம்ம சப்ளை வோல்டேஜ் 100 கொடுத்தோம் அப்படின்னா மேக்ஸிமம் வோல்டேஜ் ட்ராப் அக்ராஸ் தி கெபாசிட்டர் வந்து 2 டைம்ஸ் ஆஃப் சப்ளை வோல்டேஜ் இட் வில் பி ஈக்குவல் டு 200 வோல்டேஜ். So this is important to remember. But in case of inductor, the peak voltage is equal to supply voltage and it is happening at 0 itself. Omega t equal to 0 itself. Right? Fine, sir. Now at omega t equal to 270, what might you observe? 270 means cos 270 will be 0. So 1 minus 0 again 1. So it will be once again come back to Vs. See there, again it is coming back to Vs. Now when we are putting omega t equal to 360, cos 360 will be 1. So 1 minus 1, again it will be going to 0. So this is how we are observing the complete pattern. See there, now it's time to explore these things. If you observe the difference between inductor and the capacitor, see there. Here, the inductor waveform is completing one cycle. Yes or no? One cycle means 180% வந்து பாசிட்டிவ்ல இருக்கணும் 180 டிகிரிக்கு வந்து நெகட்டிவ்ல இருக்கணும். See there, from 90 to 270 if you observe difference, 90 to 270 வந்து total degree difference is 180 degree. So for 180 degree we are having negative waveform. Yes or no? Yes sir. Now if you observe from 0 to 90, if you observe from 0 to 90 we are having positive. Again from 270 to 360 we are having positive. For the another 180, so from here I can say 90 degree and here I can say 90 degree. For the another 180 degree we are having positive. So 180 degree positive, 180 degree negative. It is completing one complete cycle in 360 degree. In first 360 degree, in one complete revolution we are completing one cycle. If you observe the same thing for the capacitor, what you might observe, we are completing only half cycle in same 360 degree. We are observing for the same 360 degree, your capacitor waveform is completing only one half, and it is not negative anywhere, it is always positive, and its maximum peak value is 2 times of supply voltage. This is the maximum voltage offered by the capacitor. Don't forget, this is very important. I am repeating. Similarly, if you observe the maximum peak voltage offered by the inductor, that will be equal to simply supply voltage only. Okay, so these points are important points. Okay sir, can you draw this? Now I have drawn this, right? Now it is time to explore. Can you draw the waveform for inductor? Do it, because it is important for you only. Okay, sir. Now, how will you draw the waveform for the current flow through the circuit IL of t? How will you do that? So this is once again take the same intervals. Let me take 0 degree, 90 degree, 180. Yes, 0. Let us take 90 degree as usual. It will be 180 degree and it will be 270. Then we will explore. This will be 360 degree. Okay, sir. Shall we start now? Yes. Where is the sinusoidal waveform? This one. At omega t equal to 0, sin 0 will be 0. Yes, sir, it is 0. At 90, sin 90 will be 1. 1 into Vs into root of C by L. So this value will be slowly increasing to maximum value, I hope, because it is sinusoidal waveform. When I am putting omega equal to 180, it will be going to sin 180 will be 0. So again this value will be decreasing to 0. Then at 270 it will be reaching again maximum. Then again it will be reaching to 0. So here the maximum current that you can observe is Vs into square root of C by L. In the negative it will be minus Vs into square root of C by L. So this is also inductor current, current through the circuit also will be completing one complete cycle in same 360-degree. So if your capacitor want to complete one complete cycle here, what you must do? You have to wait till the next term. So see, this is one complete cycle only. But we are not observing any negative waveform. The voltage drop across the capacitor till 360-degree, it is completely positive. So we are not observing any negative voltage. I am just saying that off cycle means I am not observing any negative cycle. When I am comparing it with the other people, it is completing only positive. Other people are covering both positive and negative. So it is also covering is one cycle, but only positive. There will be no negative. When I am comparing it with other people, it will be always positive for the entire cycle. So capacitor voltage will be always positive here. So this is how the way we are analyzing this circuit. It is very important to understand in this pattern. Okay, fine, sir. I hope now you might have understand all these things. Now, 1 minute. Okay. So just do remember all these things now. Question line and exam like maybe see. First of all, you might have observed all are alternative. All the waveforms are alternative in nature. First conclusion. Yes or no? It is purely sinusoidal. If you take inductor capacitor, எல்லாருமே வந்து என்ன பண்ணிருக்காங்க? One is cosine, another one is sinusoidal. So they are alternating in nature. But input நம்ம connect பண்ணிருக்கிறது DC supply. Next, observe every peak values. That is very important, and its conduction period. Okay, that's all. Fine, sir. Now you also know the conduction period of the diode, right? So diode will be conducting till 180-degree. Okay, sir. Fine, that we have understood. Conduction time period is C. Time la வந்து எப்படி கேட்பாங்க அப்படின்னா I wrote here, right? See, you have to calculate this conduction period. They won't ask in degree. They also know this. Okay, it will be depends on the parameter value of L and C. This conduction period might be changing with respect to L and C. That's why we are deriving it in terms of L and C. Okay, it is not fixed always. Fine, sir. Now it is time to explore RLC circuit with the same DC supply and diode. Okay, so I will be bringing this is second order circuits. A little bit of knowledge need to be explored from control system. No issues if you don't remember, just to keep it as of now. While observing the control system lecture, you will be coming back to these points because I have covered everything in control system. Don't be bothered. Resistor, an inductor, then one capacitor. If RLC circuit will be explored with a DC supply, what might be happen? What kind of nature of the waveform that we will be observing? As usual, I am closing it at t equal to 0. So positive will be connected across the anode, negative will be injected across the cathode, diode will be short circuited. And now we are exploring the voltage, output voltage across R, L, C or LC. Okay, so let me draw quickly, keep all the parameters which are very important. Basically this is second order circuit. Okay, here the most repeated question is the damping factor, ringing frequency and the basic questions தான் கேட்பாங்க here because the second order circuit will take more time. So இதை வந்து எது கூட எக்ஸ்ப்ளோர் பண்ணியிருப்பாங்க அப்படின்னா control system link பண்ணி the questions will be repeatedly asked from this type of circuits in control system without diode. அங்க நம்ம அப்படியே அனலைஸ் பண்ணியிருப்போம் இல்லையா, அதை வச்சு தான் அப்படியே கேட்பாங்க டேரக்டா. So you don't need to be bothered about it. Okay, fine, sir. Anyway, it is the second order circuit. If you write down the second order characteristic equation, it will be giving you s square, 1 minute, it will be s r by l into s, and it will be 1 by lc equal to 0. This is the second order characteristic equation that we are observing for RLC circuit. We cannot directly analyze this. Okay, next here, which one is called damping factor? You all know that a damping ratio. Similarly, you might remember these things also, damping factor. So which one is called a damping factor? Basically, it will be defined in terms of alpha. The damping factor alpha equal to epsilon into omega n, natural frequency. Okay, so this is general formula. Now, what is the omega n value here? From this expression, if you compare it with the standard expression, this will be equal to omega n square. So omega n square equal to 1 upon LC, or I can say the value of omega n from here is 1 upon square root of L into C. Similarly, you can observe the value of epsilon here. See, this R by L will be equal to what? 2 times of epsilon omega n equal to R by L. Now, you can explore the value of epsilon from here. So, the value of epsilon will be R by L into 2 into omega n. So from this, the value of omega n will be known. It can be replaced by 1 by square root of L into C. If I will do that, then it will be coming back R by L into F factor 1 by 2 is appearing, most important formula. So R by L 1 by 2 into square root of L into C. Now if you observe this circuit, I am taking 1 by 2 outside first, then I am writing R, then I am writing L like this. L can be written as square root of L into square root of L. I can write like this into square root of L into C can be written as square root of L into square root of C. 1 root L will be cancelled. Now we can write R by 2 into square root of C by L. So this is the damping ratio formula for series RLC circuit. This is damping ratio. Once it is asked in GATE and once it is asked in IES and all other many state government exams. Basics. Okay, sir. Then what is the damping factor? Alpha equal to epsilon into omega n simply. Now the value of epsilon is R by 2 into square root of L by C. Sorry, it will be C by L. Forgive me. C by L. Into what is the value of omega n? 1 by square root of L into C. Now you know, see, this root C will get cancelled. Root L will become L. So simply I can say R upon 2 times of L. Are you getting me? Numerator root C. Here one root C is there, it get cancelled. Denominator root L into root L will become L again. So the damping factor, sorry, we can keep alpha, keep smile in your face. So the value of alpha will become R by 2L. This question will be repeatedly asked in your examination. Okay, sir. Now here it is time to calculate the characteristic frequency or damped frequency. Undamping frequency, damping frequency. This damping frequency can also be considered as ringing frequency. So people are calling it as omega R. You can observe this ringing frequency. It's a ringing frequency once again in commutation technique. Okay, we will be coming there. அங்க என்ன பண்ணுவோம் அப்படின்னா RLC லோட வந்து நம்ம லோட் சைடுல கனெக்ட் பண்ணிட்டு இந்த frequency வந்து நம்ம calculate பண்ணுவோம். This is called the ringing frequency. In power electronics we are calling it as ringing frequency. Application ஏத்த மாதிரி பேர் வச்சுக்க வேண்டியதுதான். That's all. Fine, sir. So we all know the formula for this ringing frequency, omega d equal to, what is the formula? Tell me. So this can be written as omega n into square root of 1 minus epsilon square. This is one way. The alternative way is we can also write this in terms of square root of, இதுக்கு முன்னாடி ஒரு ஸ்டெப் முன்னாடி எழுதுறேன். நம்ம டெரிவேஷனை பார்த்தீங்கன்னா இது தெரியும். omega n square minus alpha square. That's all. Okay. So this will be equal to omega d. You see, alpha equal to omega n into epsilon. அப்படிங்க அதை நீங்கள் சப்ஸ்டிட் பண்ணிங்கன்னா ஒமேகான்னு வெளியில் வந்துடும் அவ்வளோதான். ஸோ எதர் யூ கேன் சால்வ் இன் டர்ம்ஸ் ஆஃப் திஸ் வே. சம்டைம்ஸ் damping factor will be given in examination to calculate the ringing frequency. Remember, in power electronics we are calling it as ringing. It is creating vibration. So it is we are calling it as ringing frequency. Okay, fine sir. Now let me write the expression, let me draw the waveform of current with respect to various time period here. I cannot keep everything. I'm repeating this things already we were done in control system. I spent a lot of time. So you can observe these things in the lecture. Okay, if you observe, the waveform of under damping will be purely sinusoidal. But if you observe the waveform of over damped system, it will be like this. Then it will be going to 0. Then it is time to observe the critically damped system. It will be slightly like this. Okay, these things are a little bit important in IES point of view. This is under damped waveform. Okay, and this is the waveform of current when we are considering over damping. என்ன சார் இந்த damping பத்திலாம் பேசவே இல்லை, திடீர்னு நீங்க போட்டு என்னென்னமோ damping சொல்றீங்க. Am I right? அப்படி யோசிச்சுட்டு இருக்கீங்க. No, you should not, because these things already explored. Critically damped. Listen guys, already I have covered nature of the roots. The characteristic equation வந்து நம்ம என்ன பண்ணுவோம் அப்படின்னா இதை சால்வ் பண்ணி we will be deriving 4 type of classification: undamped system, underdamped system, overdamped system, critically damped system. So ஒவ்வொரு இதுக்கும் வந்து ஒவ்வொரு value of epsilon வந்து நம்ம substitute பண்ணிருப்போம். I hope you all have remember this. See, so basically we will be having 4 type of system here. One is undamping. Based on the nature value of this damping factor or epsilon, the systems will be categorized. First one is undamping. Undamping means the value of epsilon will be approaching to 0. Then when we are considering underdamped system, underdamping means we are keeping the system under our control. So in case of underdamping, epsilon value strictly lies less than 1, greater than 0. We will be having some controller value here. When we are considering critically damped system, everything has been explored in control system. Don't be bothered right now, you may not aware of this, some of you. Epsilon equal to 1. So when we are considering over damped system, what is the meaning of all this? Everything has been covered, don't worry. So when we are considering over damped system, the value of epsilon will be approaching greater than 1. இந்த செகண்டரி சிஸ்டம் நம்ம கம்ப்ளீட்டாக எக்ஸ்ப்ளோர் பண்ணியிருக்கோம். டயக்ராம்லாம் வரைஞ்சி ஒரு இடத்துக்கும் எந்த மாதிரி போல்ஸ் வரும், எதில் ரியல் போல்ஸ் வரும், எதில் வந்து இமேஜரி போல்ஸ் வரும், எதில் ரெண்டுமே கலந்து காம்ப்ளெக்ஸ் போல்ஸ் வரும். எவ்ரிதிங் ஹஸ் பீன் derived over there. So here I am just covering the things that is really required for us from these circuits. Okay, I hope you all have understood. So today we have learned so many things. Might be many of you know these things already. Now here I am just covering some things that we are going to evaluate in our upcoming lectures, because it is time to enter into rectifiers. Almost I have covered all the basic properties of diode. So what you understand finally, when the moment we are connecting a diode with in the left hand side I have connected DC supply, in the right side we have connected variety of load. Resistive load, then we saw resistor plus inductive load, then we saw resistor plus capacitive load, then we saw pure inductive load plus capacitive load, then we saw pure inductor, one capacitor, one resistor, we saw RLC load and its correspondent observations. Everything we have done. So now what you have understood finally, if a diode is connected, to the DC supply with a different variety of loads, these are all the loads that we are exploring. That's all. What kind of pattern that we are observing, everything is completed now. It is time to start our rectifier circuit once again back. Now I am replacing this DC supply by AC supply. Now again we are going to connect all the loads. So far what we did is We have connected DC supply and we observed its correspondent pattern. Now it's time to explore our rectification process. When I'm connecting AC supply, basically how we are observing. I have given the introduction, right? First, what we saw very first lecture in our today class. Starting, we saw when I'm connecting a DC supply with the resistor, what might happen. That is our original circuit, what we are going to do now. But it is very important to understand the behavior of the diode when it is explored connected with the DC supply. That's what we did so far. Okay, இப்போ நீங்க என்ன பண்றீங்க அப்படின்னா recollect few more things. நல்லா உட்கார்ந்து பொறுமையா அண்டர்ஸ்டாண்ட் பண்ணிக்கோங்க. You can watch our lecture to understand these things. First, understand how to calculate input power factor. Okay, I'm not going to derive anything now. I know what to do, so I'm not going to do. It is your responsibility to understand what is input power factor. Most important repeated question in many exams. So spend some time. கொஞ்சம் பொறுமையா நிதானமா உட்கார்ந்து இன்புட் பவர் ஃபேக்டர்னா என்ன, அது நம்ம எப்படி வந்து பவர் டிரான்ஸ்ல கால்குலேட் பண்றோம் அண்டர்ஸ்டாண்ட் பண்ணிக்கோங்க ஃபர்ஸ்ட். Because if you not aware of these things, you will be in trouble. First thing. Second, என்ன கேட்பாங்க அப்படின்னா you will be requested to calculate the harmonic factor. Second one is what is this harmonic factor and how to explore this value. That is your next task. Harmonic factor means what? Okay, and the next thing what you have to understand is displacement factor. What is this displacement factor and how do I explore this displacement factor? I am repeating, don't memorize these formulas directly blindly. See some lectures, it may be our videos or any other resources that you want. Try to observe these components or problems, whatever, but understand how to do this. This is one thing. Next, understand how to calculate the voltage ripple factor and in which circuits we are observing this voltage ripple factor. I need to know these things. Okay, voltage ripple factor. Next, sometimes people are asking transformer utilization factor. Okay, so learn what is transformer utilization factor. As of now, this will be sufficient. But remember, whatever the parameter that I am giving here, they are very, very important. I know there are so many other parameters, but priority will be given for these people. If you understand these things, then other things will become very easy while explaining. What you have to do, இதெல்லாம் வச்சு கொஷின்ஸ் வரும்போது எப்படி சால்வ் பண்ணணும்னு கத்துக்கணும். சும்மா பிளைண்டா ஃபார்முலா மட்டும் நோட்ல எழுதி வச்சுட்டு ஓகே இன்புட் பவர் ஃபேக்டர் திஸ் இஸ் தி ஃபார்முலா உட்காந்து அதை மெமரைஸ் பண்ணிட்டு கண்ணை மூடி மைண்ட்ல ரெஜிஸ்டர் ஆயிட்டான்னு பார்த்துட்டு இருக்கக்கூடாது. லேர்ன் தி ஃபார்முலா. ஒரு எக்ஸாம்பிள் கொஸ்டின் வந்து எக்ஸாம் எங்கேயாச்சும் பாருங்க. யூ கேன் சி எனிவேர், நம்ம லெக்சர்ஸ்ல வாட் எவர் வேர் எவர் யூ வாண்ட் டு சி யூ கேன் டூ இட். இட் இஸ் கம்ப்ளீட்லி யுவர் ஃப்ரீடம். கவனிச்சுட்டு அது எப்படி எஸ்டிமேட் பண்ணிருக்காங்க, டூ இட். அதை அப்சர்வ் பண்ணிட்டு ஓகே திஸ் இஸ் ஹவ் வி ஆர் டூயிங் திஸ் திங்ஸ். பிகாஸ் அப்ளிகேஷன் ஓரியன்டாக தான் நீங்கள் பவர் எலக்ட்ரானிக்ஸை படிக்கணும். சும்மா பிளைண்டாக ஃபார்முலாவை பார்த்துட்டே போனீங்க அப்படின்னா இட் வில் நாட் பி ஹெல்ப்ஃபுல் ஃபார் யூ. எந்த ஈக்குவேஷனை பார்த்தாலும் இமிடியட்டாக அந்த ஈக்குவேஷன் வச்சு கொஸ்டின் எப்படி சால்வ் பண்ணுறதுன்றதான் நீங்கள் கவனிக்கணும். ஏன்னா ஈக்குவேஷன் கேன் பி மெமரைஸ்டு பை எவ்ரி ஒன் ஆஃப் யூ. யூனோ நம்ம மெஜாரிட்டி ஆஃப் தி பீப்புள் என்ன தெரியும்னா இன்னொரு கெப்பாசிட்டி வந்து எல்லா ஃபார்முலாவையும் மெமரைஸ் பண்ணுறாங்க, பட் ஒரு கொஸ்டினுக்கு ஆன்சர் பண்ணுறாங்க. What is wrong with all of you? Because the problem is you know the subject, but you don't know how to apply it. It's time to explore that. Okay, ஒரு சின்ன ஃபார்முலா தெரிஞ்சா அந்த ஃபார்முலா வச்சு நம்ம கொஸ்டின் எப்படி நம்ம கிராக் பண்றது? You should think in that way. Power electronicsல there are so many numerical questions you can collect. நீங்க கூகுள்ல போட்டு பார்க்கலாம், யூடியூப்ல பார்க்கலாம், question banks. There are so many exams are there nowadays. Collect all the question. எங்கெங்கெல்லாம் ரிசோர்ஸ் கிடைக்குதோ எல்லாத்தையும் எடுத்து வச்சுட்டு இந்த ஃபார்முலா ரிலேட்டட் இருக்க கொஸ்டின்ஸ் எல்லாத்தையும் எடுத்து ட்ரை பண்ணுங்க. Explore your knowledge, become the master in this field. And I told you, aim for first mark. Don't blindly. Sir, நான் clear பண்ணா போதும் சார், எனக்கு 40 மார்க் வந்தா போதும் சார் கேட்ல. What kind of habituation it is? Try to explore yourself. Strongly believe that you are going to do something beyond all other people. Your ability should be far, far better than all other people. Okay, it is not motivation class, but understand one thing. ஏதாச்சும் ஒரு விஷயத்தை பண்ணா try to do it completely. It may take some time, கண்டிப்பா டைம் எடுத்துக்க தான் செய்யும், but you will become far better than other people. At that time நீங்க இன்வெஸ்ட் பண்ண எனர்ஜி மல்டிபிள் ஆகி it will 10 times reverted to you. If you are aiming for 1 lakh salary, you will be getting 2 to 3 lakhs minimum. So that things, but don't expect money as of now. Your expectation, you should attract the money. If you want to attract the money, explore your knowledge. When you are continuously increasing your knowledge, when you are becoming smarter than more, that is far smarter than other people, automatically you will started attracting the money. Unknowingly it will happen. So try to become a master in this field first. Understand everything. Explore it in terms of problems. Explore it in terms of conceptual questions. Okay, try to solve as many questions as possible and be active. Keep smile in your face. Be calm. Don't think about any exams. Don't bother about it. ஐயோ எக்ஸாம் வந்தா என்ன வருது, என்ன ஆகும், என்ன ஆகும், படிக்கலனா என்ன ஆகும், ஓகே ஃபைன் சார் நான் இன்னும் படிக்கவே இல்லை, இப்போ ஓகே எக்ஸாம் அனௌன்ஸ் பண்ணிட்டாங்க, அடுத்த வாரம் எக்ஸாம், வாட் வில் யூ டூ? 7 டேஸ்ல உட்காந்து மொத்த சப்ஜெக்டையும் புரட்டி பார்த்துட்டு what kind of activities it is? You are preparing for entrance exam. எந்த எக்ஸாம் எழுதினாலும் 100% வந்து நீங்கள் அக்யூரேட்டடாக எக்ஸாமுக்கு போகணும். அப்போ தான் 10 கொஷனில் மினிமம் 9 கொஷினாச்சும் உங்களால் கிராக் பண்ண முடியும். யூ வில் பி பிளேஸ்ட் இன் தி ஃபர்ஸ்ட் மார்க். டாப் பொசிஷனுக்கு எய்ம் பண்ணுங்க. டோன்ட் பிளைண்ட்லி ஸ்டடி. ஓகே சும்மா சார் கான்செப்டை படிச்சிட்டேன் சார். சம் ஆஃப் யூ சேயிங் லைக் திஸ். ஒரு 5-6 சப்ஜெக்ட் வந்து ஃபுல்லாக நோட்ஸை ரிவைஸ் பண்ணிட்டு எல்லாத்தையும் மைண்டில் ஏற்றிட்டு சார் ஐ ஹவ் கம்ப்ளீட்டட் 6 சப்ஜெக்ட். இஃப் ஐ வில் கிவ் சம் 10 கொஷின் அவுட் இன் திஸ் 6 சப்ஜெக்ட், 2 or 3 கொஷின் கூட ஒழுங்காக கிராக் பண்ண மாட்டீங்க. தென் வாட் இஸ் தி பாயிண்ட் ஆஃப் ஸ்டடிங் திஸ் 6 சப்ஜெக்ட்? Studying in the sense, explore your knowledge. Everyone can study and understand. It is your responsibility to apply this. Application oriented. Problematic அதை நம்ம எப்படி crack பண்றது? Conceptual questions வந்து எப்படி crack பண்றது? Your zone will be in the third place. Learning itself, don't think that you are completing everything. First you should learn. Then you should understand all this properly. Then you should apply. Applying zone is the important zone. இது ஃபுல்லா சப்ஜெக்ட் நீங்க படிச்சு முடிச்சதுக்கு அப்புறம் தான் உங்க டாஸ்கே ஸ்டார்ட் ஆகும். Don't think that while studying itself you have completed all these things. No, you should explore your knowledge here. For that, what we need, repeated practice, solving thousands of questions. Okay, fine sir. Now in the next lecture we will be starting diode is completed, we will be starting rectifier. Okay, but I cannot cover everything. Okay, I can just revise. So it is your responsibility to cover everything, and then I will be dropping some important thing, then directly we will be entering into problems. Okay, this is all for this lecture. Remaining things we will see in the next class. Thank you all.